Welcome to Electronics Sneaky. So in this video we discuss about Carry Lookahead Adder. So Carry Lookahead Adder is nothing but it's like another version of 4-bit parallel adder. So there is some disadvantage in 4-bit parallel adder. So that's why we go into the Carry Lookahead Adder. So what is a 4-bit fill adder? We just give some overview. So 4-bit parallel adder or Carry Ripple adder both are same. So for that we are using 4 bits means so 4 full adders we are going to use. So it is second full adder, third full adder and fourth full adder. So for every full adder there are the 3 inputs A0 and KB and Cn, and we get sum as the carry. We all know about this. So we already discussed the code of the carry ripple adder also. So like that get final carry here sum. So these are the S0, S1, S2, S3 like that. So it is our final cout carry. So what is the problem with that means, so here you can see, so first this operation is going to be done. So A0, B0, so A1, B1, these all will give at a time. But what is the carry issue is going to be run, so it may be some delay, means first this full adder will be operating, then by this the carry will be generated, and this output carry is going to be input for the second full adder. Until this carry generated, this full adder is going to be wait. So there is some delay of operation of this full adder. So for that what you are going to do means, so we can calculate the carry in before in the carry lookahead adder. So in carry lookahead adder what you are going to do means, so we are in before calculate the carry by using the formula. We are going to calculate the formula for carry, and directly we are going to apply by this, no use of these no purpose for waiting for this carry. So we are directly calculating carry, so there is no delay of carry passing. So here is some delay after this operation done, there is some delay here and some delay like this. So there is no chance to delay. So that's why we are going to the carry lookahead adder. In that we can reduce the carry delay process. So how we are means, it seems the block diagram like this. So here we can use propagate and generate. So here P represents the propagate and G represents the generate. So by using these formulas we are going to calculate the carry. So this is our carry. So what is the formula of carry means Ci. So if I value is equal to 0, so C0 is equal to Gi means G0 plus E0 into Ci minus 1 is nothing but minus 1. So like that we are going to calculate the C0 value. So what is the formula for G0 means, so Ai into B means A into Bi. So it means end operation AB. So P means A XOR B means we are represent like this in Verilog, this is represented like this. So these are the formulas for the propagate and generate. By using this propagate and generate we are going to design the carry, and you directly apply the carry to the our full adders, then you can simply design that. So here you can see there is some formula. So some formula is nothing but C XOR of P. So carry is XOR with propagate, then we get carry. So here you can see the block diagram same here. So how you get propagate and generate means, so we get XOR operation of A and B, we get propagate, and by AND operation we get generate. So how you get sum, so C and P are going to be XOR operation, we get sum. So at that time we can by using this P and G we are going to calculate the C3 by using this propagate and generate. Like that we are going to calculate the carries, and there is no delay of particular carries. So just look into the code, just remember these formulas. By using these formulas we are going to write the code. So what are the gates we are using, simply you can implement in the code. So just remember that C formula is G plus Pi into C, and like that generate formula, propagate formula and sum formula. Let's look into the program. So here it is the time scale 1 nanosecond. Here from these videos I am going to execute these codes in Vivado tool. So why I use the Vivado tool means that in Vivado you are access the schematic diagram also. So when your code is turned into the schematic, then you can understand the internal structure also. So it seems like this. So by using this the internal structure, what is the internal happen, how they are connected, you also know. So these programs are little bit more than before one, so it may be better to know how the internal block diagram. So that's why I prefer Vivado. You can prefer EDA Playground also, no problem at all, but there is no schematic diagram in EDA Playground. So that's why I use Vivado. If you want how to access Vivado tool, if any problem to use this, you can comment it. I will make a particular video how to use the Vivado tool in your laptops like that. So until then just look into the code. So time scale 1 nanoseconds per 1 picosecond means what is the waveform we are representing. So it must should be nanosecond or picosecond, that's why we represent it. So defaultly it gives that this first line, so no need to write this first line. So next here you can see this is our code starting. So followed it's like module, start with module and end with end module. You know the syntax. So followed by module name. So now you are going to give the inputs and outputs. So what is our inputs? So ABC are our inputs and sum and carry are outputs. AB are the 4 bits and carry is 1 and the sum is again 4 bits. So means 1 0 1 1 0 1 1 0 like that. So it is our carry. So by using this we get sum. Means 0 carry with 1, 1 carry with 1, 1 and then 0 carry. So it is our carry. So it is our sum. Like that we are going to calculate by using the carry lookahead adder design code. So here we inside what you are in this propagate, generate, these are the internal bytes. So no need to mention the particular input ports or output ports. So just these are the input ports and these are the output ports. So just see A, B naught, A1, B1, A2, B2, B3, B3. These are the inputs and C naught, C4. So C naught is nothing but in this code I represent C naught with C in. So your C1 is nothing but C naught, C1, C2 and the C3 final. So like that we represent in the code. So just see this is our final carry. So we can simply represent like that only. So see here. So AB, so A naught, B naught, C A1, B1, A2, B2, A3, B3 like that. And C naught is our C in here. So this is the sum and final carry. So there is a propagate, generate and what are the carries we are using here. See. So there is a C1, C2, C3 and C0 means C1 is I represented C1 with C0, C2, C3, C4. So here in this code, so those are just bytes. So no need, there are not an inputs, not an outputs. It's just used by connecting the one pin to another pin, one port to another port like that only. So no need to write these are the input ports or output just to represent by byte. So no need to store the particular value. We just use the bytes in between the code. So in between the design, so while, so you represent with while. So what you are using propagate, generate and carry. Simply write in the while. So now what is the formula for generate, what is the formula for propagate, you simply represent here. So in previous video I already said primitives. So primitives. So what is our primitives? Primitives nothing but there is a inbuilt keywords means XOR and so these are our inbuilt keywords which are used to a directly operation. Means how you write the primitives means. So first you have to write the gate. So what you are going to implement, for which gate you are want. If you want XOR gate, so you simply write XOR. If you write AND, so you simply write AND. So followed by if you want to write any instance name, you can write. So no otherwise no need. So just followed by outputs, followed by inputs. So everything there is only one output. So if there is number of inputs, so if it is a 2 gate XOR gate, so 2 inputs are there. If 3 gates inputs, so 3 inputs are there. So here what is the formula for AND gate? So AND gate, there is a generation for generate. What is the formula? AB, we get the generate G. So A of 0, B of 0. When you give A of 0, B of 0, you get G of 0. So you simply write AND. So followed by output. So what is our output? G of 0, comma. Yeah, what are inputs? A comma A of 0, comma B of 0. So end with semicolon. Like that, these 4 lines are going for the generate purpose. So these are the formulas for generate. Next what is the propagate? So these 4 are the formulas for the propagate. So for how you get propagate, so here is the formula. So propagate is nothing but A XOR B. So but different P of 0 means A of 0 and B of 0 are the inputs. So like that these 4 lines are for propagate. So next what you are going to do, sum. So for sum what is the formula? So sum C XOR P means carry XOR with P. So we simply write XOR operation of outputs followed by inputs. So next 4 lines are going to be carry. So carry is not in any gate, so it is just formula. So that's why I use assign keyword. So by using these assign keywords, you are going to assign the RHS value to the LHS value. So you already know about the carry formula. By using that, we simply represent like this. So finally, your carry is like C of 3. What is the value of C of 3? It is going to be our carry. So end with AND module. So it is our test bench code. It looks very simple. See, module followed by module name. So you all know about the syntax. So what are the inputs? We simply represented in reg data type. So these are the inputs. So what are the outputs? We simply represent in the output. So followed by you have to instance that design code in the test bench code. So these line is our connection of design code and test bench code. So how you are going to instance me? So you simply write the design code module name. So what you represent here in the design code module, same exactly write the same thing and followed by instance name. So you can use any name, you can use your name also, no problem at all. But you prefer DUT. DUT means design under test. So followed by these are the port connection. So port connection by name order, you can prefer anything. So there is a less number of input and output. So that's why I use order. If you want, you can use port connection by name also. What is a port connection or how you can represent, I already done a video. If you don't watch, you can go watch, then you can understand what is the order, what is the name, how you are going to connect by using order, how you are going to connect by using name, you can understand very well. So there is the initial begin. So inside the initial begin, we are going to give the different combinations of inputs. By different combination of inputs, A value is going to be 4-bit means, so 4 tick B 0001. So A value is going to be like this, B value is going to be like this, and C, these are carry. So after some delay, so /5 represents some delay. So when you are giving some delay, then after you are going to give some other different combination of the inputs. So again some delay. So if you want to stop the simulation, then simply write the finish keyword. So by using finish keyword, you want to stop the simulation. So at a particular time period, I don't want to simulate for further process, means you want to simply write /finish. Then there is no further execution of the simulation process. And these begin. What is the initial begin? So there is a multiple statement. The search by you is begin and end. So the stop by end. So module is end with end module. So like that you can represent the test bench code. So you just remember that. So test bench code is very simple. Syntax is very simple. So for every code, start with module and end with end module. I say the test bench code only. So maybe design code is changes according to the our application. So but test bench code is every time having the same syntax. So it is our test bench code. So module followed by module name, and you simply write the inputs. What are the inputs we take in the design code? So simply reg data. So inputs are representing reg data type. So outputs are representing byte data type. So it is a every code, it is a common syntax, and followed by instance module name. What is the design code module name right here, and the followed by instance name. So design code module name and instance name followed by port connection. So then initial begin and then end. So in the initial block, we are going to give the different combination of input combinations we are going to give. So for every code, it will be the same. So first followed module by module name, inputs are represent reg, outputs are in while. So next we are going to instance the design code module here, and the initial begin and give different combinations and end with end module. So for every code, this is the only syntax we are going to follow. We can give anything, you can take any code. This is the syntax of the test bench code. This is the basic syntax. So for any program, the basic syntax of the test bench code is like this. So just remember this syntax, then it is going to be very easy to write any code. So whatever the long code you are given, so just remember the inputs and give different combinations. So you know already the functionality, and according to the truth table, you are going to check whether you are doing or not by using the waveforms. So in every video I write 4 lines, but here I don't write. Means in Vivado inbuilt there is inbuilt there are the waveforms, so no need to write the particular 4 lines. But in EDA Playground, if you are going to use, then you can write the particular 4 lines. So what are the 4 lines? In previous video I already say what are the 4 lines. So if you watch this video first time, means if you want to put this code in EDA Playgrounds, and then go watch the previous video, there is a 4 lines which is extra than this code. So you can use that and you get simply waveforms. So if you have any doubts about that also, you can say I can give separate code and in another video. So until then we are go to the schematic. So it is our schematic diagram. So it is our schematic diagram. So what you are going to means, there is a AB are the input. So by using this what are the code we write. So here you can see, so you can write the code. So according to our code, these gates are going to be arranged. So this is our final carry, this is our final sum, A, B, C or C in. So here you can see A, B are going to some XOR gate. So this again XOR is going to be another sum. So again these A and B are going to be another AND gate. So like that what are the code we are write, that will be represented in the schematic. So once cross check your code with your schematic diagram, then it will be matched. So that's why you can understand very properly when you are understand the code. So like that every operation, so what you are write the code, so what are the code you are written, so it will be exactly similar to your schematic. So just it is our waveform. So for this our first input, so this yellow color line represent the values here. So here the values are A value is equal to 1. So 1 means it is a 4 bit, so it means 0 0 0 1. So B value is E. E means it's like 1 1 1 0. It is our A. B is equal to E. So it is a 4 bit, so that's why I represent 4 bits. Plus Cn. Cn is only 1 bit, so it is 0. So now you are going to add 1 1 1 1. So it is the value is F, and carry, there is no carry means 0. So you can cross check whether you are doing correct or wrong. Carry lookahead adder is nothing but addition, but without any delay of carry. So it is a main difference between the 4-bit carry ripple adder and carry lookahead adder. So until then, if you have any doubts, you can comment it, and thanks for watching. and then bye.